El Nino, where did it come from? The name actually comes from the Spaniards who colonized South America late in the 1800s. They noticed this warm water showing up off the coast of Chile, Peru, and so on. And because it was coming around Christmas time and it made for some nice warm beaches for a bit around Christmas, they called it El Nino, as in the child, the boy child, the Christ child around Christmas, because they thought it was a gift from God. But of course, El Nino also creates fish kill and birds, marine birds die, and so on and so forth. Nonetheless, much later in 1920s, Walker discovered the southern oscillation. He was looking for the reasons why there were droughts in the monsoon, and he had data from Tahiti and Darwin, and he looked at the pressure difference and realized that they were oscillating together out of phase. And Tahiti is usually cold and high pressure, Darwin is warm and low pressure. And when this was the situation, Indian monsoon used to be normal. He thought it was normal during that phase, and then when Tahiti got anomalously warm and low pressure happened, and Darwin got anomalously cold and high pressure happened. Southern oscillation is what he called it, because both are to the south of the equator. That he found had a high correlation with the monsoon. Only in the 1960s, Jakob Birknes came back, that I mentioned before, who discovered this ocean atmosphere interactions and called it a coupled mode, or in El Nino, that he related it to the El Nino that Spaniards had discovered. So basically he said it's a coupled mode. I'm fumbling this a little bit, but later on El Nino, which is a very nice name, was made very nondescript by combining with southern oscillation, because El Nino and southern oscillation are the same. So we call it ENSO now, El Nino southern oscillation. La Nina, as we said, is the opposite phase of El Nino, colder than normal in the east, warmer than normal in the west. Teleconnections from the two, the global impacts, are not exactly symmetric, as we'll see later, but they are essentially opposite phases of the same phenomenon. Now we call them warm ENSO and cold ENSO. We call it La Nina because you cannot call it anti-El Nino. El Nino is Christ child, so I think George Philander of Princeton came up with the name La Nina, and it has stuck, and it's a nice little name, means little child, girl child, not to do with Jesus, but just the opposite phase of El Nino, the Christ child. Coming back to 2026, you can see how things have evolved. There are indices that are used to track El Nino. So there is Nino 1.2 in the coastal regions, which is getting warm this year. Nino 3 is in this central eastern Pacific. Nino 3.4 is from the eastern to the central Pacific towards the dateline. Nino 4 is in the western Pacific, and all of those indices can be tracked during a strong El Nino like this year's one seems to be evolving towards. You have warm sea surface temperature anomalies appearing in Nino 4 already by April, in Nino 3.4 here already by April, and of course also in Nino 3 and Nino 1.2, 1 plus 2, sorry. Okay, that's the coastal Nino, eastern Nino, central Nino, western Nino. You can think of it that way, and they are pretty close to each other, but the coast has warmed much more. It's at 2.1 degrees C anomaly by now already. That's pretty warm, and not all El Ninos end up this way. We'll see later that actually we have something called a central Pacific El Nino, which means the warming happens here, and we have canonical El Nino, which means the warming happens here to here, and we have mixed El Ninos or extreme El Ninos when El Ninos get very strong. We call them extreme El Ninos. Now the word super El Nino is being used. These are all made up because essentially El Nino is El Nino. Its intensity can change, but when it crosses 2 degrees C anomaly in this Nino 3.4 region, some people call it super El Nino. Does it have super impacts? Not always, but just says how strong the El Nino got. Okay, and in the meantime, every El Nino looks different. So if you look at the oceanic Nino or Nino 3.4 index from 1950 to about 2025, you can see that there have been La Ninas, there have been El Ninos. This El Nino looks like it hardly went away and came back. This one lasted maybe almost 2 years. Little ones here, bigger ones here, 82, 83. This is 65, 66. This is 80, 72, 73, I think, or 68, 69. 72, 73 was strong, 82, 83 was strong, 97, 98 was strong, 15, 16 was relatively strong, 24 was there, as we saw, and so on. So each El Nino is different. There are details. El Ninos typically last for 9 to 12 months. Warm water gets exhausted, whereas La Ninas, for many dynamical reasons, can persist for multiple years. You can see that most of the La Ninas are lasting longer than 1 year. You can think of it as a normal state being amplified, so trade winds remain, positive feedback, stronger trades, things can go on. More and more cold water can be brought up, but La Nina, El Nino is where you are spilling the warm water that's been built up. We'll see later how it builds up, and that tends to exhaust the source of warm water, and then El Nino disappears, dissipates, and then we have to build it back up. Interestingly, Enzo is the Zen circle of enlightenment in Japan, and each artist draws it separately. So each Enzo looks different. Similarly, each El Nino looks different. Each Enzo looks different. But is there anything fundamentally the same for all El Ninos? This is a key question, and we'll try to answer it a little bit based on some of the past work by some people I know. Okay, see you in the next little story on El Nino, continuing story of El Nino.